students, today we are going to study about cube roots of unity that comes under complex number. So first of all, we will see definition of cube root of unity. So the root of unity is a number which is complex in nature and gives 1 if raised to the power of a positive integer n. Okay, so what are its properties? First property is one imaginary cube roots of unity is the square of the other. We have, for example, if I'm taking an equation x cube minus 1 is equal to 0, then it will have 3 roots because its power is 3. 1 omega denoted by 1 omega and omega square. So this one is real and these two others are complex. So here one imaginary cube root is the square of the other. We can see here like this. This is the first cube root of unity. We have squared it. By squaring it, this is a minus b whole square, a square plus b square minus 2ab upon square of 2, that is 4. By solving it, we will get this, and this is the second cube root of unity. Similarly, this is the second cube of unity, and by squaring it, we will get the first cube of unity, cube root of unity. Second property is if two imaginary cube roots are multiplied, then the product we get is equal to 1. First is 1, second is omega denoted by omega, and second is omega square. If we take the product of these three altogether, it is 1. So obviously when it will be multiplied to any number, then it will give the number itself, and the product of these two imaginary roots comes out to be 1. Now next, their sum is 0. If we take the sum of these 3 cube roots of unity, then it comes out to be 0. You can see by adding all these 3 cube roots of unity. So here you can see cube roots of unity as we have taken x cube minus 1 is equal to 0. By using the identity of a cube minus b cube, that is a minus b, multiplied by a square plus ab plus b square, we will factorize it in this form, that is x minus 1 and x square plus x plus 1 is equal to 0. So here x minus 1, when equated to 0, it will give 1, and the other two roots by applying the quadratic formula, that is x is equal to minus b plus minus under root of b square minus 4ac upon 2a, will get two values of x, that is omega and omega square, and both of these are complex. So we can see from here that one is real and the other two are complex. Similarly, if we talk about the positive where x cube plus 1 is equal to 0, then its root will come out to be minus 1 minus omega and minus omega square. And if we take x cube plus 8, where 8 is the cube of 2, then the roots will be minus 2 omega and minus 2 omega square. Now here our first question is the roots of the equation x minus 1 ka whole cube plus 8 is equal to 0 are. So here we can just put y in place of x minus 1, so it will become y cube plus 2 cube is equal to 0, and obviously it can be taken as y cube plus t cube, so its roots will be minus 2 omega and minus 2 omega square. And if you put x minus 1 in place of y, and when this 1 will go to this side, then it will get added to the respective roots, so the roots will become minus 1 minus 2 omega and 1 minus 2 omega square. So our option B will be the correct option. Next question is omega that is not equal to 1 means we have not to have take that one, that cube root of trinity, and 1 plus omega square k whole power n is equal to 1 plus omega raised to the powerful whole power n. And the least positive value of n is. So here we will equate it, and from the relation that is 1 plus omega square is equal to 0. From this relation, if we take 1 plus omega square, then it will come out to be minus omega. So we'll put minus omega in place of this. And 1 plus omega raised to the power 4. So omega raised to the power 4 can be written as omega cube into omega. And omega cube is 1, so it will come out to be omega. So we'll take here in place of this. So it will become 1 plus omega, and 1 plus omega will be equal to minus omega square from this relation. So putting all these values, we will get minus omega whole power n is equal to minus omega square whole power n. By dividing it, we will get 1, and by solving it, 1 upon omega whole power n will be equal to 1. And it can only be possible if the value of n is 3, since omega cube is equal to 1. So only when its power is 3 it is equal to 1, and its reciprocal will also be equal to 1. Therefore the value of n will be 3, so B will be the correct option. Now this is the question of the day. Is cube root of unity collinear? So you need to find, is cube root of unity collinear? So just find out. If it is collinear, then write it in the comment section, and with the um, proof also, that why is it so. We will discuss it later. So this is all for today. Thanks for watching.